we discussed the two algorithms so far.
Recording is on.
Okay, so we discussed the two algorithms so far. One is reversing the entire list, and then reversing the pairs, right? So I can run those two problems. So here is the reversing the list, and here is the two functions here, reversing the pair, which has another function which we'll call reverse the pairs. So let me run this and show you. Okay. So what I did here is couple of linked list I created. Here is the main program here. So I created 1, 2, 3, 4 given linked list. Why it's taking a long time? So first I'm just printing and then reverse the linked list. I'm reversing the entire linked list, and then here is the reverse linked list. I'm printing again, and then I'm reversing the pairs. Okay, after reversing the pairs, I'm printing the list again. Okay, let's see the output. Okay, here is the thing. So 1, 2, 3, 4, that's the first one, and reverse the linked list. If I reversed it, the entire list, right, like this, 4, 3, 2, 1, and then we are reversing the pairs. So here is the reverse the pairs, right? So if I reverse just these two, right, pairs means just two elements, right? So 3, 4, and then 1, 2. 2, 1 becomes 1, 2. So this is the given list, and this is a reverse step pairs. Now, given linked list is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we need to reverse list in a group of 3. This is the third algorithm we are going to discuss. So how can we? So if I say K means rather than saying a pair, I will say take reverse K elements, reverse 3 elements or 5 elements at a time, and the list could be very long. So how can we do this? So this is the, if I say group of size 3, right? So here is the result. So if you have like this, 1, 2, 3 becomes 3, 2, 1, and then 4, 5, 6 becomes like 6, 5, 4, and then 7, 8, just 8, 7, because we don't have 3 elements, but we will still reverse those, whatever the elements we have. Only 2 elements, let's reverse those, 8, 7. Okay, so that's the algorithm here. So now if I say reverse the list, linked list, the group of 5, so what happens? 5 for the given list, 5, 4, 3, 2, 1. No, sorry, I am reversing these elements, this this linked list, not the original one. So what happens? 5, 6, 1, 2, 3, and then remaining elements 7, 8, 4. See, so these are the 5 elements we are taking, and we are reversing those. So if I say there are two approaches, we can use extra space and a recursive algorithm. Recursive algorithm is exact same result, right? So if I say size of 3 again, so I can reverse this to 1, 6, 5, and 7, 3, 2, and 4, 8. That's what we are doing here. So let's look at the things. How can we do this? Okay. Here is the reverse list. Here is the reverse pair, and here is the reverse nodes K. Okay. So first one, approach one, using additional data structure. So what data structure will help you to do that? Okay. So let's write it down here. Let's say we have the list like this: 1, 2, 3, 4, 5, 6, 7, 8. Right? That these are the elements we have. Okay. So now K equal to 3. Let's say K equal to 3. So how can we do this? So we need 3 elements, like, and then process those 3. and then again next three elements, and then process. So any idea which data structure will be useful, and what is the way to do it? You know, so we cannot take these many variables, right? If you look at the reverse pairs, we simply took three variables: first node, second node, a third node. But if you have five, you need to take five variables. If you have 10, we need to take 10 variables, which is really, it's not dynamic way of doing, right? Like pairs, we can know just by taking one extra variable, third node, we can do it. But if you want to do three or five nodes, it's not good to take that many variables, right? So like first node, second node, third node, fourth node, fifth node. So that's not going to scale, right? So how can we do, in an efficient way? If you are okay to use extra, data structure.
So like we can use array, like it will store the node and data address as well, like of a fixed size like three.
Yeah. Okay. You are taking array, and what are you going to put in this? So you're going to put one, and then two, or same node, the entire node, not just the value, right? You're going you're going to put the nodes here.
Yeah, like node and address as well. Like we will
Yeah, yeah,
also need.
entire node.
Yeah, yeah, yeah.
Exactly,
Okay.
entire
Yeah.
node. Yeah. Mm-hmm. So, which is good idea. Yeah, actually, that's I did not think about it, but that's perfectly all right. Because we know what size we need, right? If k is already given, you can just initialize the array with three elements, and you put those three elements into the array, and what you do with them. So you place those elements in the array, right? Then
Yeah, yeah.
how it will be helpful? Then what you do, we need to reverse, right?
Yeah, so like like I don't know, like we can reverse the first and last node, like in the one, two, three array.
Actually, we don't need to do like that. We need to reverse. We can simply navigate from last element, and we can say, hey, the three dot next equal to two, two dot next equal to one. We already stored the elements in an array,
Yeah,
right? So we there is no way of losing of the elements. So you processed it three times, you processed k times, and you placed all those elements in the exact same order. You know that first element is here, second one is here, third one is here, and you simply go back and link those in a reverse way. So by end of that, you will have like this three, two, one, right? Correct.
Yeah.
yeah, yeah,
Now what we need to do? We need to do the same process for next three elements, right? Only catch here is once you do this, this particular chain needs to link to the next chain of elements. This is next chain of elements, right? It could be three or it could be five. Only thing is, once you're done with processing, that could be the previous node for this chain. It's exact same process what we are doing. Previous. This previous is we need to be in our minds, because we always need to make sure the previous element, that should be pointed to this updated chain, right? So basically, for the first chain of elements, previous is null. There is nothing. We no need to worry about the previous element, because this is the starting of this whole thing. But if you are processing the mid of the linker list, we always need to make sure that there is a previous thing that should point to this updated linker list, or updated chunk of elements, right? So here we will update using array, no problem. But once update happens, that previous address, the previous node, should point to that updated shuffled linker list. So that means 4 5 6 becomes like 6 6 5 4 You simply follow the same elements, right? So follow the same approach. 4, 5, 6. You put it in an array, and then you navigate the array from the back to the first. Basically, array has a very easy way to navigate, right? You can simply say n minus 1 for loop. You can write loop from n minus 1 to 0, right? So that way you can navigate from back to front, and you can link those elements. So 4, 5, 6 becomes 6, 5, 4. Now previous needs to points to the first element of this chunk of elements, right? So that's what we need to track. Now what happens to the previous? Now the previous becomes 4, because that's end of this chunk, end of this block of elements. Let's say n k equal to 3. Once you process all this, the last element will be marked as previous. That will be pointed to the post processing of remaining elements. Correct? So basically we will follow the same pattern. We will keep track of the previous address. So I hope you got that problem, right? So, but it's very interesting. So we can use array. And what is the other best mechanism? Because array here, the problem here is it's not a problem. It's exact same. It's exact same. Complexity or the same logic. So what is the another best algorithm or best data structure which will give you in a reverse way? Basically, we need to process these three, right? One, the order is like this: 1, 2, 3. We want 3, 2, 1. So if you are taking 1, what is the best algorithm which will give you the results in the reverse way? Last in, first out. What is that?
Stacks?
Yes.
No.
So
Yeah, stacks.
stack is, yeah, that's right. So if you are putting in an elements in a stack, it's exactly the same way. Of course, there is not much difference. Both arrays are same. So we simply put the elements in the stack. So as you're processing, basically, in order to process a bunch of elements, you can take array as it is. As Modit said, that's perfectly fine. So but in this algorithm I took the stack. So basically you're processing 4, 5, 6, let's say, or you're processing 1, 2, 3. You're putting 1 and then 2 and then 3. So you put 3 elements. Now what you need to do, you need to pop each element and link each other, link one after one, link them in a reverse way. So 3, 1 to 3 becomes 3 to 1. So using a array is also perfectly fine. There is no difference, because the stack also we are taking the space of 3 elements. Whatever 3 means, k elements, right? So even in the array also we initialize array with k elements. There is no much difference. Only thing is just logic change. In the arrays, you will put it there and use a for loop, which will navigate back to the first element. Stack, you can simply pop the elements. That will already give you the elements in a reverse order, right? So that's the additional data structure implementation. Let's see if you want. Did I miss anything? I think that's yeah, I think it's a simple one method. But this next one will be, I think this requires 2 methods, or let's see. So we will look into the next algorithm after this. So basically using additional data structures, now we are we are going to use stack. So Modit, is it clear? Modit and
Yeah, it's
Vanilla,
clear.
everybody.
Yeah, it's clear.
So basically there is no difference. Basically you can, as you said, you can use the array as well. You can try using array, but I used stack here because that does the same thing, right? It will
Yeah.
give you the
Yeah,
elements in a reverse.
yeah. Even using stack is good also. Like
Yeah, it's
we
quite
will.
easy.
Yeah,
Yeah. So what are we doing here is simply we are initializing. So we are saying reverse nodes k. Okay. So we have a head which is on the top of the algorithm. We have head, and we can also send head here. It's not a problem. So the algorithm can take head. So now what are we doing here is we are initializing stack, we are initializing current, we are initializing previous. Exact same variables as I said. Current is like which element you are processing, and previous is always we need. Every algorithm, if at any of these algorithm, previous is very important. The variable which we are keeping track. So previous initially null, and we are doing this as long as current not equal to null, do this entire algorithm. So the entire what is happening inside this, terminate the loop whichever comes first. We are terminating the loop when either current equal to null or current greater than k. So basically count greater than k. So what are we doing here is, as I said, we have a very big linked list. We are doing a loop here. So basically current not equal to next or count less than k. We are putting three elements into the stack, three or k elements. That's it is right now. So current equal to current dot next and count equal to count plus plus. We are just having a counter to put three elements into the stack. That's it. It's very simple logic. So but what happens sometimes, as I said, there could be only two elements here. There is no three elements. That's why we are having a second condition. So if you have three elements, put the three elements. But if in case if any at any point of time current becomes null, that means we have less than three elements. That's okay, because we are just exiting the loop. We don't want to process the null. We don't want to put null into the stack. There is no point of putting null node into the stack. That's why we are make sure the node is not equal to null, and also count less than 3 if k equal to 3. Okay, so that's the termination logic here. Terminate the loop whichever comes first, either current or count greater than or equal to k. So if count equal to 3, this second condition will fail and then it will exit the loop. So basically this whole thing is we are just processing, we are taking k elements and putting into the stack. Okay, now pop the elements of the stack one by one. So while stack count is greater than or equal to 0, it's just simple while loop, right? Okay, take each element. If the final list has not been started yet, so what are we doing here is simple check here, is previous equal to null. That is null because we initialized with null. That means we are processing the first three nodes. We are that's the meaning of this if condition. If previous equal to null, whatever comes from the stack, that will be the previous, and that will be the head as well, right? So if you look at the diagram again, we are previous equal to null. We initialized previous equal to null. That means we are processing the first pair of elements, a pair or k number of elements, first three elements. Now we are putting in the stack and we are popping whatever the first comes out of the stack. That will be the previous, and that will be the head as well, because this is head, right? So the new head is basically this element. Correct. Is it right? Whatever comes from the stack. So now we are updating the head and we are stack.pop, and then we will go again here, and the next one is previous equal to null. No, previous we already said, previous we already marked as 3 as our previous. Now what are we doing here? Previous dot next equal to stack.peak. Peak is basically the next element, right? So it won't even pop it, but it will look what is the peak, what is the the top element. So what are we doing here? Previous dot next equal to stack dot peak, and previous equal to previous dot next. So basically previous is right now 3, previous is 3, and 3 pointed to the stack dot pop, stack dot peak, basically 2. Now previous equal to previous dot next. Okay, then this becomes previous. Now we are popping this. Okay, take this element completely. Okay, now what happens? Next element 1 will come up, and previous equal to previous dot next. That means 2 dot next equal to 1, and this becomes previous. Previous equal to previous dot next, right? Which is 1. Now stack dot pop. There are no more elements in the stack. By the time we complete 1, 2, 3, what happens is 1 becomes previous, 3 becomes new head, right? So we are modifying head only here. If the previous is null, that is the only situation we are modifying head. We don't want to change head at any point of time. Okay. So by the time we complete the first 3 elements, head is 3 and previous is 1. Okay. So now what happens is we go back here, and current, what is current here? Interesting. Current becomes 4, right? This is where the current pointed after 3 nodes, right? After taking 1 and putting in stack, after putting 2 and 3, all these 3 we are putting in stack, but at the time current pointed to 4. We stopped because we reached 3 elements, right? So current is still pointed to 4. Now we are asking, hey, let's put another 3 more elements in the stack. So now stack becomes like this: 4, 5, 6. Again 3 elements. We stop there. Current points to 7. So we'll wait for these 3 elements to shuffle. So current is still there. We follow the same pattern here, right? So stack is not null. Previous is also not null. Now previous dot next equal to stack dot peak. That means previous is already pointed to 1. 1 points to 6. That's what we need, right? So we already modified 3 to 1 becomes 1 to 3 becomes 3 to 1, and 1 points to 6. That's what we want, right? And the next this becomes previous. So now 6 becomes previous, and then 6 points to 5, and then 6 becomes 5 becomes previous, and 5 points to 4. So finally again 4 becomes previous. So 6, 5, 4. By end of this, 4 becomes previous. And then we'll go back here and we will take the elements into the stack again. But at this time we have only 2 elements, right? We have only 7 and 8. That's okay. We'll put 7 and 8 in the stack, and we follow the same pattern, and we'll swap them into 8 and 7. 8 and 7. Now at the end of this loop, let's look at previous dot next equal to null. Next of last element will point to null. So the reason here is, by end of this, what happens is 7 7 becomes previous, right? But 7 dot next is 8. So 8 already here, and 7 dot next is also 8. It's like a loop. We created a loop here. So that's why we need to point previous dot next equal to null. So that's what we need to do here. This is a kind of bug fix kind of thing. You completed looping, you completed the shuffling, but if you forget this, you're creating, technically you're creating a loop, right? So basically what are we
Yeah,
doing is we
I
are
have
just,
done that.
what is that? Can you repeat
Yeah,
the
I
question?
have done that. That was the
Yeah.
mistake.
Oh, you practiced and you did that. Yeah, it's a really
Yeah,
important step,
created a
because
loop.
yeah, it will create a loop, because previous points to this element, right? The completed element. Basically, at the end of this, previous point to 4, but 4 next is still pointed to 5. Basically 6 to 5, 5 to 4, and 4 points to 5. After processing 7 and 8, we are processing 4 points to 8. right? That's the step we are doing. And at the same time, 7 points to 8. So 8 points to 7, but 7 points to 8. So 7 and 8 will be a loop kind of thing. That's why we are saying, okay, take 7 and assign to null. That's how we are finally will get 3 to 1 and 6 5 4 8 7 and 7 points to null. So that's the main step here. So by end of this loop, that's actually the whole algorithm. We no need to do anything because we already modified head here. We no need to return anything. So this is the whole algorithm which will um, reverse k elements at a time. Is it clear? So first we discussed it's just use a loop or stack or array. It looks like simple, but while writing again, little complexity here. What are the different cases we need to tackle? How to, when to change the head, right? And how to modify the, previous elements, how to track it. So it looks very simple steps, but understanding takes little while. Okay, is it clear, Cecilia, Modi, Karanya, everybody?
Yeah, it's good.
Cool.
Just one
Yeah,
question.
basically,
Yeah.
yeah, go ahead, go ahead. Yeah,
Like in interviews or like in tests, we can use the inbuilt stack, like any inbuilt functions. Like it's fine to use, right?
yeah, we are using inbuilt stack. You mean like peak or pop, right? You're asking about this?
Yeah,
Yeah,
like we can use
definitely,
inbuilt stacks. Yeah. Sorry, inbuilt.
definitely. Yeah, because
Yeah. Okay.
inbuilt library of the stack,
Yeah.
right?
Yeah.
Yeah, definitely. The reason here is like if I ask this question, I'm looking at the logic how you build here, how you managing the addresses. I don't care how you design stack. That designing a stack itself is separate question, right? How do you build a stack?
Yeah.
Actually, it's interesting. Actually, they using link. There is a stack using linked list. There is another algorithm. Yeah, basically that's a good question. So so another interesting question is, hey, build a stack using linked list. Don't use library. Using linked list. So how do you build a stack? Because that's always tough, right? If you are looking at the so if you build a linked list, this is how it is, right? So that's interesting question. So but in this question, definitely they don't look for implementation of stack at all. Okay. So you are building, so 1 2 3, you are building like this, but at any point of time you will simply give one. But I want, if I say pop, I want to pop three, right? So how can we do this? So that's I think build a stack using linked list is an algorithm, I guess. So where it will give the first one, give the last one.
Yeah.
So if I say pop, we need to pop three. So if I ask you to build a stack using linked list, what you need to do is you need to put one, and if I say push two, you need to do like this. If I say push three, you need to do like this. This rather than linking like this. If you link like this, you can simply say if I pop, okay, I will give you the first one. So basically, if I say a build a stack using linked list, you simply push the element to the head of the linked list. Very simple. So maybe I can draw a different way. So you understand, I'm explaining a different problem altogether. So it's a very good question you asked, Modi. So if we can also practice that. Build a stack using linked list. That means, hey, push one. So head points to one. Okay. Now push two. If I say two, now head points to two. Okay. 2 points to one. If I say three, I will create a three element and head points to three, 3 points to two. So that means three to one. If I say pop, you simply say, hey, this is the head, take it, and head points to head dot next, which is two. So now 2 1 1 remains. So basically, you keep adding element at the beginning, that simply makes you kind of creating a stack. You don't add at the end of the linked list, you add at the beginning. If you add the elements at the beginning, you can simply give you that element when somebody calls pop. Last in, first out. Correct?
Yeah, yeah, that's quite
So
interesting.
that's yeah, that's quite interesting. It's a function. It's another interesting algorithm where you need to write pop, you need to write push, you need to write count. By using just another variable count, you can maintain. As if you are removing an element, you decrease the count. If you are adding an element, increase the count. And a peak is just give me the value of head, right? Just head dot value, that's it, peak. So what are the other elements, other methods on the stack? That's it, right? Only count, peak, push, and pop. So yeah, it's kind of homework for you guys. Let's try it out. It's of course it's available in the online, but don't look at online. Try to build that algorithm and see. It's very simple, just updating the head always, right? So is it clear?
Yeah, it's clear.
Yeah, is it clear to others, Vanilla or
Yes,
Karanya,
sir. Yes,
obviously.
sir.
Yeah, it's another problem. You can simple problem to try it out. So cool. Yeah, this is quite interesting and simple, I guess, right? So we are using a stack to process k number of elements, and here is the built-in stack we are using, and it's kind of dynamic. What is called templating, right? We are saying a stack with the node. Every node we are putting in the stack. So let's do without additional data structure using recursion. Instead, we can use recursion to do the same thing. So without using any additional data structures. So in this case, what we need is we need reference to the head. Here is the head node and k. It's basically, if you use recursion, it will use stack behind the scenes, right? It's not a rocket science or anything. Basically, instead of we creating a stack, we are asking system to create the stack by using recursion. So what are we doing here? I looked at last night, but again I forgot the algorithm. So it's always tricky. So simple. If head equal to null, just return. Otherwise, current, previous, next. It's a kind of three variables we are managing. So we are taking current, next, and previous, and count equals 0. Reverse the first k nodes of linked list. So we are reversing first k nodes. So it's just like it's a reversing a linked list. So by using current, next, previous, we already did this. This is exactly the first algorithm we did. So reversing the entire linked list kind of thing, right? The same thing, previous and next. It's the exact same algorithm is repeating here. Next equal to current dot next, previous, the current dot next equal to previous equal to current, and current equal to next. Exact same algorithm, same lines. Only thing is we are incrementing the counter. We don't want to do for entire list. We will do only k nodes. If you do k nodes, just come here. That means we already processed, let's say we processed first three nodes, right? Now next is now pointer to k plus 1th node. That's what I did, right? I showed you last time. So once you complete three elements, the next node points to here. In that algorithm, current node pointed here, but here next variable points to k plus 1th node. Recursively call for the list starting from the current and make rest of the list as next of the first node. Make rest of the list as next of the first node. Okay. Next not equal to null, and head dot next equal to, okay, why are we saying head? Okay, head dot next equal to reverse nodes next and k. Okay. So now what are we doing here is we are changing the head dot next. Oh, I know why. Okay. So basically what are we doing here is, hey, here is the list. Okay, and here is the head, and process 3 nodes. We are always saying process 3 nodes. Next time we are saying here is the head and process 3 nodes. Okay, so we are sending the entire, instead of sending the head here, we are sending the next node here. So we are sending to the same, we are calling the same method. Now instead of calling head, instead of putting the value of the head, we are saying k plus 1th node. Basically next is now pointed to the k plus 1th node, right? So basically you can think of this as a sub problem. We already processed these nodes. Now I am giving the entire list. This is the entire list, and here is the head. So 4 is the head. You can think of 4 as a head. So now from 4, do k, process k nodes. That's what we are doing here. So again, it comes from 4, and it will start the same algorithm, and it will reverse the 4, 5, 6, and then head dot next. That means 4 dot next. 4 dot next equal to process the remaining list. That's the catch here. So head, why it is head dot next? Head is always like, this is what this becomes, the head becomes the last element of after processing, right? After processing three elements, the four comes here. Now 4 dot next is equal to process the remaining elements. Process the remaining elements, and that will be linked to that. So that's what we are doing here. So head dot next equal to reverse the rest of the elements. Now previous is the head of the input list. As I said, previous is the head. So if you look at this algorithm, right? So the previous becomes 3. After processing 1, 2, 3, previous becomes 3. That will be the head of the new list, right? 3, 2, 1, and here is the head. So if you process, oh my god, this becomes so messy here. So if you process 4 and 4, 5, 6, what will be the head? If you process 4, 5, 6, 6 will be the head, right? If you are thinking as just 3 elements, so this is a list, just 3 elements, and head is 4. But if you process this function, now 6 becomes head. That means this will be the previous. So in this algorithm, previous equal to current, and current becomes next, and count plus plus. So by end of this loop, previous points to the last element. Basically that will be the new head. Now 6 will be the head. So that will be pointed to here. It is tricky, but if you are understanding, if you are going through the program again and again, that's you understand. So basically we are processing 3 elements, and then we are saying like, okay, next element will be process rest of the elements, and we again process 3 elements, and then 4 dot next equal to, okay, process the rest of the elements. Yeah, something like this. See, exactly is the way recursive function works, is almost same as like the stack. So we did using stack. I think using stack is way easier to understand rather than understanding this whole thing. So it requires if you are putting many breakpoints, we can understand how this is working. Start debugging. Let's see. Is it clear, or is it still confusing?
Yeah, it's clear, but need some practice to understand.
Yeah,
Yeah, it needs
yeah.
some. Sure. Definitely. Yeah. Okay, head equal to null, and now let's see if I continue, what happens. Okay, count is here, and current is 5. So what is the list here? Oh, 5, 5, 5, 5, 6, 1. We have 5, 6, 1, right? That's the thing. So we are processing those 5, 6, 1. So if I continue, all the way. So let me show you. Yeah. Now see what is the previous. What is the value of the previous is basically 1. So because you are taking 3 elements, right? 561, we took 561, and now previous is 1. That is the head, right? That is the head of this whole thing. Now head dot next. Head is 5. Head dot next. That means 5. We already processed like 561 becomes 165. Now 5 dot next equal to process the remaining list and give me the head. We don't know. If you are processing 3 elements, 7 will be pointed to 7 will be the next element of 5. If you are processing 6 or 4 elements, 1 2 3 4, 8 will be the next of 5. Correct? That's what we are doing here. Head dot next equal to, head is 5 right now. Head is 5 right now, but head dot next equal to process the remaining list and give me the head. Give me the head of that. Give me the first element that will be connect here. Okay. So it is tough to understand, but that's the main thing here. So now see this. So next is, what is the value of next here? 2. See, process from 2, rest of the entire list. But how many nodes you need to process? Only process 3 elements. Start from 2, process 3 elements, okay, and give me whatever the node I want to connect to this 5. Why? Because 5 is already here. You already linked 1 to 6, 6 to 5. Now we need to process what is now 5 pointed to 6, which is something we want to change. It's kind of loop. It's kind of loop we created at this time. Since after this loop, after this whole while loop, what happened here is 1 pointed to 6 and 6 pointed to 5. But 5 dot next is still 6. Let me show you. If I go ahead here, head, and 5 dot next equal to null right now, because that's the previous. Yes, previous. So right now what happened here is 1 5 6 null. That there is a break in the chain happened. 5 pointed to null, because that is how we created this whole algorithm here. Previous, right? Previous equal to null. We are assigning previous to that value. Previous is null, but we need to change. So 5 dot next equal to process the entire list starting from next node, and process only 3 nodes and attach that head, attach that whatever the element. That means if you're processing 3 nodes, it will give you the 7. That's the previous. That 7 will be attached to the 5 basically. So I can show here and put a breakpoint and continue. So now it's recursively doing it. See that now we are processing 2, we are processing 7, no, 3, we are processing 7. So here, now what happens here? 2 dot next here. Okay, now next not equal to null, next equal to null. Let's see. Yes, so now we are sending 4. We are sending 4. Yeah, we are sending 4 as the value to the other one. So we are those are the 3 elements, right? So that 8 4, I think if you are processing 8 4, 8 becomes in a previous. Okay, it's keep returning all the values. Yep. Okay, we got the final list here. I exited with the code. Huh? Yeah, we got the results, right? See, 1 165 and 732 and 48. Okay. Cool. Yeah, that's the main algorithm here using recursive way, but I know it's a little tricky. I would definitely prefer, using a array or a stack. This is way simpler and easy to understand, I would say. So this is very important question in terms of uh, you know uh, interviews. So both the questions and explanations are given here. If you go to the Geeks for Geeks, so both of them are explained clearly. I did my, I tried my best to explain this, and it is always better to go through these steps here. They have these kind of really nice diagram as well, and here is steps how you're doing it. And there are different algorithms like C++, C, Java, Python. You can understand any of those. And if you want to run C sharp, you can also run C sharp algorithm, which I'm going to share. And here is this method too, which is using the stack. So both the methods were explained here very clearly. Some of the people will put videos as well, really nice. So is the it's only in C++. This particular algorithm only in, oh no, it's in C sharp as well. JavaScript also. Yeah. Yeah, you can go through this, or you can also go through the algorithm which I'm going to send. It's almost same thing, no difference. Cool. Any questions? Modit and
Like,
Cecilia, is it clear? Yeah.
yeah, yes, sir.
Yeah, it
Yes.
takes time to understand the basically the changing the pointers, changing the addresses is the main key. It requires a lot of practice. I request you to practice on the pen and paper. That's the only way to remember. So I don't know if these are complex in terms of interviewing. I never ask these questions in interviews. I always ask strings and arrays. Always like strings and arrays. I never go to linked list in my interviews because it makes nervous, right? It's like it's not easy to remember these tabs, and it's not easy to write in a 100%. They can give some details, okay, I you update this, update that, and we'll take this variable, but it's tough to complete this whole algorithm unless we have full grip and full practice. It's a matter of practice. So if I'm asking this algorithm, basically I'm testing his practice rather than I'm testing his skills, how much he practiced for that. It's just like Olympics games. If you are practicing more, you will win it. If you don't practice, you don't. You know how to run, you know how to do it, but knowing is different and practice is different, right? They are testing your practice, and in the sports, similarly here they are testing their practice rather than they are testing their skills. So it's something. Some people will like it, and I don't like to ask these kind of complex questions. It definitely makes the interviewer or the candidate nervous, right? So I Yeah, but practice makes perfect. That's as we know. If you are practicing more and more, you can at least attempt, and you can at least go through the at least kind of I would say 70% right algorithm. It may not be 100% runnable. It's okay even if you miss this line or the last line or a couple of lines, but at least if you are, let's say, this while loop is 100% correct, then it's okay. Or some, at least some of the algorithms or some of the lines, if you are making without any bugs, without any problems, then it's okay. So as you said, I think I don't know whether she left. She said she forgot to update this last line. This is very important line for the entire algorithm. Without this, it will create loops. So you're end up creating a loop. But it's okay to miss this in the interview. It's okay because unless you run it, you don't care. But if you are writing the entire algorithm, rest of the algorithm properly, then it's okay. So that's my take on it. But it requires a lot of practice. So cool. Next week we'll look at this cloning of a linked list and other things. Very interesting algorithm. I like this. So let's see. Cool. Okay. If no other questions, we can wind off. Have a nice rest of the week. Okay. Okay.
Thank you,
Any
Suresh.
questions?
Thank you, Suresh.
Thank you, Suresh.
Awesome.
Thank you so much.
No problem.
Yep.
No
Bye bye.
problem. Okay. I will send the links of this algorithm. Cool. Bye. Bye, everyone.
Bye.
Bye, Suresh. Bye.